One experience you're very likely to encounter in your ordinary everyday life is the need to buy a car and to take out a car loan. So, in section 8.6, we are going to consider the mathematics of calculating the payment for a particular car. We're also going to examine the other costs associated with owning a car. Let's begin in 8.6.1, learning how to calculate a car payment. First of all, we need a little bit of vocabulary. Definition: an installment loan is a loan that is paid with equal payments. Those equal payments are called installments at a fixed interval of time over a specific term. So you could very easily take out a simple interest loan and pay it back in installments. You could do the same thing with a compound interest loan. However, car payments are usually based on a different formula. When part of each payment is used to pay the principal, that is the amount that you borrowed, and part is used to pay the interest, the loan is known as an amortized loan. So every single payment designates a portion to the principal and a portion to the interest, and those portions change month to month. This type of loan is commonly used to finance cars, as we will examine in this section, and homes, as we will examine in the next section. The payment on an amortized loan is given by this lovely formula here. The payment in an amortized loan is always going to be the same every month. But again, the amount that is designated for principal and the amount that is designated for interest changes month to month. And we're going to explore all of those differences. Let's make sure that we understand what all of the variables represent in this formula. First of all, P is our payment. So if you have a car out there that you've had your eye on, you know the price of the car or the amount of your loan. Okay, you can assume maybe that's the price of the car. Then this formula will convert that price into your monthly payment. Other things you need to know are what's the rate of interest for the loan. You can look that up and research best rates. N is the number of payments per year, or the number of times interest is compounded on that loan per year. Those are going to be the same. And finally, T is time in years, or the term of the loan. With a car, it can be anywhere from 2 to 8 years. So let's experiment with this new formula. Example 1. Calculate the difference in the monthly payment for the following two options. So you're out there shopping for cars, you've got your eye on a particular make and model, and you've got two options. You have a new car option, so the new car costs $19,000, that would be the amount of your loan, and can be financed with a 3-year loan at 6.18%. The other option is the used car option. So you've got a 2-year-old model of the exact same car, but this one costs $11,500. And there is a significant difference between the price of a new car and a 2-year-old model of the same car. This one can be financed with a 3-year loan at 7.5%. Let's calculate the payment for both options. We're going to start with the new car option. Now let's record our formula down here in our workspace so we can see where everything gets plugged into the formula. So the payment P is equal to the amount of the loan times R over N divided by parentheses 1 minus parentheses 1 plus R over N exponent negative NT. So we're looking for the new car option. So the new car is $19,000. So I'm going to plug that in for A. The rate of interest for the new car option is 6.18%. We know that has to be a decimal, so 0.0618. We're going to be making monthly payments on our car. That's the usual setup. So in the denominator, we have parentheses 1 minus, parentheses 1 plus. Now, those ones do not cancel because this second one is in a set of parentheses underneath an exponent. So don't be tempted to cancel those ones. Our rate, again, is 0.0618. N is 12. Notice our exponent here is negative. So we have 12 payments, and we're going to do this for 3 years. So let's calculate what our car payment would be. We're going to type everything in exactly as we have it written in our formula. So 19,000, open parentheses, 0.0618 divided by 12, close parentheses. Big divided by for the big fraction bar, open parentheses, 1 minus, open another set of parentheses, 1 plus 0.0618 divided by 12, close parentheses. I'm going to hit my exponent key, and now we're going to enter a negative exponent. On your calculator, you have the minus operation over there on the right side of your keypad, but the negative sign is located down here below the 3. It's the little negative in parentheses, so I'm going to use that for the negative sign. If I try to use the minus operation, my calculator is going to give me a syntax error. So negative 12 times 3. Now I'm going to use my right arrow key to get down out of the exponent position and close parentheses, and then press enter. So our car payment is going to be $579.57. $579.57 for that new car option, and that's a 3-year short-term loan. Now let's consider the other option. Let's look at our used car option. We're still using this same formula, so I'm going to keep my eye on that, and we're going to plug in our new values. This time the amount of our loan is $11,500. The rate's different on this one, 7.5%, 0.75. We're still making monthly payments, so N is 12 divided by parentheses, 1 minus, another set of parentheses, 1 plus, rate 0.075 divided by 12, exponent negative N, which is 12, times time, which is 3. Okay, let's get this one typed in and see what the difference in our payment's going to be. 11,500 times 0.075 divided by 12, close parentheses, divided by, for the big fraction bar, open parentheses, 1 minus, that's the minus operation, open parentheses, 1 plus 0.075 divided by 12, close parentheses, exponent key, now I'm going to use my negative button in parentheses, 12 times 3. Okay, right arrow key to get down out of the exponent, close parentheses, and press enter. So our car payment here would be $357.72. What's the difference between the two payments? Well, we're going to take our first payment, $579.57, and our second payment, or our second option, $357.72, and we'll see what the difference is. The difference is $221.85. That is a big difference for a monthly budget. Now, cars do depreciate in value. So they say as soon as you buy a new car and drive it off the lot, it begins depreciating in value. What that means is when I sell it back, I'm not going to be able to sell it for the original price that I paid. I won't be able to recap my investment. I'll only be able to sell it for less. So oftentimes it is a wiser decision to choose a used car option, simply because the value difference comes from depreciation, not necessarily because the car is of lesser mechanical soundness or anything like that. Just happens to depreciate. Homes, on the other hand, are different. They appreciate in value. Generally, they increase in value. So another thing I want to point out about this one, our second option had a much higher interest rate than the first option, but because the second car had such a lower sticker price, it had a much lower monthly payment. So something to consider as you contemplate the possible need to take out a car loan. Let's do another example. Example 2. Suppose you decide to borrow $15,000 to buy a car. Given the two following financing options, determine the total interest paid for each loan. So you've picked out a specific car. The price is $15,000, and you're comparing loans. You have loan A. It's a 4-year loan with an 8% rate. And your second loan option, it's a longer term, but you have a higher interest rate. So we're going to compare these two loans by figuring out over the term of the loan, what's the total amount that I pay for interest. Now keep in mind, as I make my monthly payments on this car, a portion of the payment is going to reduce the amount that I borrowed, that is to pay that back, and then a portion is going to cover the cost of interest. So let's see how this translates into total interest paid for each loan. Part A, find the monthly payment for loan A. So we're going to start with loan A. We want to calculate our monthly payment. So I'm going to write our formula down again. If you write it down a couple of times, it becomes a little more familiar to you. And this is one that I would definitely want to keep handy for when you do have to go out there and shop for cars. You can calculate your own payment without having to depend on a salesman to give you that information. Okay, so the amount of our loan is going to be $15,000. For loan A, the rate of interest is 8%, and we'll type that in as 0.08. We're going to be making monthly payments on this loan. So N is 12 payments per year. Open parentheses, 1 minus, open parentheses, 1 plus, 0.08 divided by 12, exponent negative n. Remember, number of payments is 12 per year, and we're looking at a 4-year term for this loan. So let's calculate the monthly payment for this first loan. Payment for loan A would be $366.19. Okay, let's do that again. Let's calculate the loan. We're still on loan A. Calculate the total interest paid for loan A. So how in the world are we going to figure this out? Well, we have paid $366.19 every month for 4 years. Let's calculate the total amount that came out of our pocket. This is going to be the total cost of the loan. This is going to be our monthly payment, 12 times per year for 4 years. So $366.19, 12 times a year for 4 years. The total cost of this loan, $17,577.12. Now, $15,000 of that was the price of the car. So the difference between the total cost and the initial amount borrowed is the total interest that we've paid. So the interest then is the total cost minus the amount borrowed. So we're going to evaluate $17,577.12 minus the $15,000 that we borrowed. That's going to give us a difference of $2,577.12. Okay, so when we make this $366 payment, part of it is going to reduce this principal and other part of it is going to pay interest. When the loan is complete at the end of 4 years, we will have paid $2,577.12 for the interest charge alone. Okay, we're going to repeat this for loan B. Let's find the monthly payment for loan B. So I'm going to use this same payment formula. The amount of the loan is the same, but for loan B, our rate is going to be 10%. So we're going to plug in 0.1 for R. We're still making monthly payments, so N is 12. And the term of the loan is different. We're going to do this for 6 years. So we have a longer time to pay back this loan. Let's see what our monthly payment would be for this setup. Okay, this one would be a payment of $277.89. $277.89. Now, the payment on loan A was a little bit higher. Notice it was a shorter term loan, so we didn't have as much time to pay back the amount that we borrowed. That translates into a bit of a higher payment. On loan B, since we have a longer time to pay it back, it translates into a lower monthly payment. So at this point, that sort of makes loan B attractive. But let's go ahead and calculate the total cost of this loan. Total cost of this loan. This is going to be $277.89 every month. That's 12 times per year. And remember, the term of this loan was 6 years. So let's see how much we paid for this loan over those 6 years. Total cost of this loan, $20,008.08. Let's figure out, translate that into how much interest did we pay. So we're going to take the total cost of the loan minus the initial amount that we borrowed, $15,000. And that's going to give us $5,008.08. If I compare the total amount of interest that I paid for option B, the one with the longer term, to the total amount of interest that I paid for the shorter term loan, then obviously loan A in the long run will be cheaper than loan B. So question E says, which is the better option and why? Well, there's kind of two sides to this story, right? Financially, loan A has a smaller total cost, but a higher monthly payment. Loan B has a higher total cost, but a lower monthly payment. If you have the option, then loan A financially is the best choice, right? Even though it has a higher monthly payment, you end up paying much less in interest over the term of the loan. However, there are those situations in life where you have to take out an emergency loan. Let's say you're driving a car and the engine goes bad and you have to buy a new car. Then you may want to go for the longer term loan to keep a lower monthly payment that gives you a little bit of wiggle room in your budget so that you can also cover tuition costs. That should be your last resort, right? Going for the more expensive loan. However, I am going to show you options that you can do to pay off a loan early. You can take out this longer term loan, and when the opportunity arises, you can pay it off early and save that money in interest. We're going to experiment with that in later videos. This works for car loans. This also works for home loans. So truly, loan A is the best option, but in an emergency situation, you could certainly take out loan B, give yourself a little bit of wiggle room with that monthly payment, and then when the opportunity arises, pay the loan off early and save yourself some costs and interest. We'll talk about those strategies in a later video. Now, I hope that you hang on to this formula. I hope that you experiment with it. What is the car that you are considering? How does that translate into your monthly payment? What are the interest rates that are available out there? So that you can take this knowledge into your own hands and convert the price of your car into what would that be in terms of a monthly payment. So find that very interesting, and I hope that you do as well.